Swayam Prabha. Digital India. Educated India.
Good morning. Welcome to this second lecture of ongoing online course on Engineering and Architectural Graphics Part 2. Yesterday in the lecture 1, we saw the fundamentals of isometric drawings, and from today we are going to continue discussing about different objects and how do you draw them in isometric projections using isometric projections, and the resultant we are looking at isometric drawing. So, we are not actually taking the isometric lens, we are doing directly the drawing using true lens. So, you always have to remember this difference between isometric projection and isometric drawing. So, what we will be doing for most part of the course is isometric drawing. So, in this lecture we are going to look at the isometric drawing of quadrilaterals and polygons, the straight line polygons. We are not doing the curves here, no circles, no ellipses, nothing, and it is only going to be straight line planar objects. Now, before we start looking at these examples and I start explaining to you how do you draw isometric drawings, we will again revisit the fundamentals very quickly, and I will try to revisit these fundamentals before every lecture, at least for a couple of initial lectures, so that you are able to understand how do we actually convert these orthographic drawings into isometric drawing. So, first very clear rule is the lines parallel to each other, they remain parallel, which is what we have seen. So, anything which is any line which is parallel in the original object will remain parallel to each other even in the isometric drawing. The second one is the lines which are parallel to the axis, they remain parallel to the axis. So, if it is parallel to x, if a line is parallel to x axis, it will remain parallel to the x axis in isometric drawing. Similarly, for y axis and z axis. The third one, all projection points are arrived at by arriving at their parallel distances, which is what I was mentioning to you in the last lecture when we saw that if there is a certain point for which the reference in terms of distance from x and y is not available, then we actually have to derive that and then go back in the isometric drawing to draw that, which is what we mean when we say all projection points are arrived at by arriving at their parallel distances from the reference lines or reference planes. So, these are the fundamentals, and I will explain the concept of isometric drawing taking examples only. So, today we are taking quadrilaterals and polygons. Okay. So, the first one which we are taking here is a simple square. Okay. We are going to draw a simple square in multiple positions. I will try to draw even at an angle to certain reference plane, not to both the planes. Okay. So, here we are going to be looking at inclined to one of the reference planes, but we will start with the simple position. Now, suppose we have a plane which is perpendicular to VP, and parallel to HP. So, it is going to be kept like this, parallel to HP. Now, what we suppose this is the origin, this is x, this is y, and this is z. That is what we are going to assume. Now, what we have is that this square plane which is parallel to HB. This is 40. So, suppose at whatever height it is 1, 2, 3, 4, assuming 1 unit is 10 equal to 10 units. Very clearly you can see that this is the plane which is parallel to xy. So, this plane is parallel to the plane. If I extend this axis, you can see that this say is x axis, this is y, and this is z. So, this plane, this resultant plane A, B, C and D is parallel to the xy plane. A very simple condition here. Let us assume another condition. What if it is perpendicular to the xy plane and in such a manner that the plane is parallel to xz? That is one condition. So, I take another, it is parallel to xz. Now, this is xz. So, if it is parallel to xz, we will have these lines being parallel to either x or z. So, the plane is vertical, we have kept it vertical to xy. So, we will have two vertical lines, which is what we see here, right, and it has two lines, two edges which are parallel to x. This is another condition. The same square could be kept in such a way that it is perpendicular to xy plane and it is parallel to xz. There could be another condition where this plane is perpendicular to xy, but it is parallel to yz. Okay. So, what we have z and this is y here. Again the same plane, a square plane, but the condition here is that it is parallel to yz. Parallel to z implies that we will have vertical lines, okay, vertical edges, and we will have another two edges which are parallel to y. Here it was x and z, here it is y and z, here it is x and y. So, these are three simple conditions in which this square plane could be kept. Now, what if this square plane is kept in such a way that it makes an angle, okay, it makes an angle with the x axis or the horizontal plane, right. So, it is making an axis with an angle with xy plane basically. Now, how do we actually derive at the lengths now? The moment it is inclined, the slant line is a non-isometric line. You have to remember that. So, I will first draw the orthographic projection and then we will understand. So, I am erasing these. I hope you have already understood this. Now, if I draw the orthographic projection of this square plane which is making certain angle with the horizontal plane. So, what we will see in orthographic projection is from the top to start with, we will actually be seeing the square plane kept parallel to horizontal plane, and in the front elevation we will just be seeing a line which is parallel to xy. Okay. So, now I have to incline it say by 30 degrees. So, what we have, we will draw, this is 30 degrees. So, you take this projection and now this is the plane as seen in front elevation, we bring it back. So, what we have, there is the new thing which will be seen is actually this. Now, if I am drawing this here, now what will happen? So, what we have is draw the original plane first. So, what we draw, if the original plane was here, this was say the same dimensions. Okay. So, this was parallel to xy. Now, we say that it is making an angle with the horizontal plane. Now, how do we get that angle? So, what we actually have is this height which is coming here. So, what we have is this rectangle which we will be seeing from one of the sides. So, suppose this is increased and now this is the reduced dimension. So, what we do is we take this dimension say approximately here and the height that it gives you. Okay. We make this rectangle which is what we are seeing from the front elevation and we draw this line. Okay. So, this is what you will be seeing in the front. The same thing we will do at the back. This is the line, and since it was, now if you look at it from the top, we will see that these two lines are parallel. These two lines which is representative of this are parallel. these two lines are parallel. So, this is the one and this is the second. This is how we arrive at how this plane will look like. It could have been the other way around. I will draw it again. Now, suppose if we have the same plane, so we start with this, and this is just for explanation, okay. You may not need to draw it. Now, the same thing which we have done in the previous one, we will do it here. So, whatever this distance comes, the height that it assumes, okay. So, we make these two, these are just for reference, these are going to be in very light lines, and then we have these lines which are actually derived out of this rectangle. This is the square we are talking about. So, this is the square which is inclined. This is what we are talking about. The same thing could actually happen in other planes as well. We could have this plane vertical, but slightly inclined. So, again we will do the same thing, reference, we will just take the reference. Okay. So, if we have it like this, we will probably take the reference rectangle, got this line in the bottom. The same thing we will have, say, at a certain height, maybe this, whatever the height is, and then we will at the same height we will again create. So, we will take this height, at this height we will again create the same rectangle, because this object what we are talking about is a square where the edges are going to be parallel to each other. It is much simpler to draw edges which are parallel to each other because of the fundamental of isometric projection which we know. So, now the same thing here and then we connect. Okay. This is the final plane in isometric. If it is perpendicular to the horizontal plane and it is kept at an angle with one of the other planes, that is what you are going to get. It could be the other way around, there could be many possibilities. Okay. The only thing which you have to remember very clearly here is, if it is simple position, no problem. In case we have non-isometric lines, in case we have isometric lines, then you can very simply draw it, just measure on the isometric grid and you will arrive at that. In case not, in case of non-isometric lines, you will have to arrive at the reference points in isometric lines, okay, the ones which are parallel to x and y, which is what we will do every time we have to create this isometric drawing, which is what we are doing here. Let us look at more examples and you will I will make it very clear. Okay, this is simple, again rectangle. I will draw all these various conditions. So, suppose this is this rectangle, I will just draw parallel to HP, perpendicular to HP, inclined to HP and at certain angle to HP, perpendicular to HP, but at certain angle to the other vertical plane. Okay. So, suppose it is kept simply like this, which is parallel to HP. This is what the rectangle would be. So, A, B, C and D. Simple. Its lines being isometric lines parallel to the isometric grid, we get it simple, parallel to a horizontal plane. Other condition, when it is perpendicular. So, what we can have possibly is this, right. Now, here it is going parallel to xz. Okay. The rectangle remains the same, the dimensions remain the same, we are just measuring them on isometric grid. Okay. So, this is another case, simple case. The third case could be this. Okay. So, this is another one. Now, you can again reinforce the principles that we have been following. Anything which is parallel in the object. So, you will always see BC is parallel to AD, BC parallel to AD, BC parallel to AD, BC parallel to AD. Whichever way it is kept in isometric, BC will remain parallel to AD because it is parallel in the object. The same thing, AB parallel to CD, AB parallel to CD, AB parallel to CD, AB parallel to CD. It could be, it is dependent upon how the plane is kept, but the fundamental remains. Parallel lines of the objects remain parallel to each other in the isometric drawing also. First. Second thing, any line which is isometric, which is parallel to the grid lines, will remain parallel to them and of course to each other. So, we see this AD, AD, AD coming depending upon which position it is in. So, these are three fundamental the basic positions of assuming how this rectangle could be kept. You can draw them all. Now, again, if we are inclining it, suppose we are inclining it by 45 degree. So, what we will do? We will actually be making the orthographic projection first. So, if this rectangle is kept in such a way that it makes a certain angle, it is perpendicular to VP, but it makes a certain angle with horizontal plane. So, what we will do? So, we will, I am just drawing an orthographic projection here. Suppose this was the rectangle from the top if we saw originally, and now if it is making say 45 degrees. So, what we have is that it makes certain angle, you bring it back, this is the new one. Okay. So, what we have is this is the new reference rectangle for containing this plane, which is what we will now draw here. So, what we have here is we have this reference rectangle. So, we have say this reference rectangle, and this reference rectangle gives us the one of these lines, okay, one of these edges. Now, you could make another reference rectangle wherever it comes out to be. So, we have this and then this will remain parallel. Okay. Maybe I should start drawing at a bigger scale, but this is something which you will get. Okay. If we were to do it the other way around, you can do it like this. Okay. We will make the reference rectangle, and at whatever distance we will make another reference rectangle like this. So, we arrive and okay. So, now you can see that I made a mistake and I immediately realized it because the line is not going to be parallel. The mistake that I committed was, here I measured say 3 units by 2 units. This is the reference rectangle which is helping us arrive at the non-isometric line, the slant. And here what I did, I took 4 and 2, and the moment I draw say this is not parallel to this. I can immediately see that this is not parallel to this. So, my fundamental basic is violated. So, I know there is something wrong. Okay. So, I will draw this again. So, if you keep these fundamentals in mind, you will actually be arriving at the correct projections all the time. Now, we will get it right. This is the final object, which is what we are going to get, right? Simple. All you have to do is arrive at this reference rectangle, which is isometric line, which is parallel to the isometric grid, and we will get these final shapes. It could be any condition. All you have to do is arrive at this rectangle and you will draw the same thing here and you arrive at the final object. We will look at another example. This one is triangle here. Now, this PQ is the reference rectangle which we are talking about. So, this is just the reference. Okay. Our actual triangle is this. Now, since this AC and BC, these are non-isometric lines, we cannot establish where this point C will come. Okay. There are two ways of doing this. One very simple is, we make this rectangle and we know how much is PC and how much is CQ, and we do it like this, okay, which is rather the way. So, this is what we are going to do here. So, I will draw it again in all the 3 conditions A, B, C. So, what we have to draw is A, B, Q, P basically. So, we have this A, B, Q and P, where it is parallel to HP. And now, somewhere on this we will have this C. So, this PQ, this is the PQ which is equal in length. So, what we are taking here is the same length, equal length, and now we will identify C, A is there, B is there, and we simply join. Okay. Now, can you see that it appears quite skewed? It does not look like what this ABC was. It looks slightly skewed, the angles are not the same. So, the angles will not remain the same in isometric, the angles will always change, right. But a grid line which is parallel to the axis will remain parallel to the axis is the basic fundamental. So, we got this. Suppose it was kept the other way around, we would have done the same thing, AB, PQ, okay, and we arrive at C. So, A, B, C. Now, you see we get it is the same triangle which we are getting here and here, it is exactly the same triangle, it is just that it has been kept, the rotation is slightly different and we will see a different looking object in the isometric drawing. It is essentially the same drawing, it is just that the orientation is slightly different. So, we see it differently. Okay. This is what happens in isometric drawing. Now, I can make it vertical. So, we do the same thing, repeat the same exercise. I am doing it repeatedly so that you understand how do we have to draw. These are fundamentals, we are just on planar drawing. The moment we move on to the solids, we will have these planes coming together. See, another triangle, it does not look like any of these two. It could be the other one, again I will draw. You see this A, B, C, the fourth possibility. So, you can have it whichever way you want. Now, suppose this is further inclined. Now, what do we do? How do we do? Again, we will have the orthographic projections. Okay. So, we will again make the orthographic projections. Suppose I say that it is kept in such a way that this triangle originally was kept like this. Okay. And I will make the reference rectangle. So, A, B, C, P, Q, okay, and in the front elevation you will be seeing this, and now we incline it in such a way that this edge remains in HP and this is inclined say by 45 degrees. So, you bring it back. Now, what happens that this P comes here, this Q comes here and this C comes here. So, this is the new top view. Now, what we know actually is this is what this reference rectangle is going to be in elevation and this is what this new reference rectangle is going to be in the plan, which is what we will take to the isometric. Okay. So, we will take these reference rectangles in isometric now. So, what we have here is, suppose it is inclined like this. So, we will have say this here. Okay. This is the other rectangle which is what we have here, say P Q, and this was say B dash A dash and Q dash C dash B dash. Okay. And I make this again. Okay. So, what we have here is these are these two rectangles. Now, we still do not have the triangle, we will actually arrive at A, B, Q, P. So, A, B, Q, P. This is the reference rectangle which is containing this C point. Okay. And now, we will mark this point C here, whatever this distance is. So, we know this. So, this C will be marked here and now we will join. So, anything that we are going to draw in isometric projection is what we are going to see here. So, this is the final ABC which is at an angle of say 45 degree here, which is what we assumed, and it looks very different. It could be again in the other side. So, we will again be arriving at the rectangle which contains ABC triangle which is here. So, this is the rectangle which is containing ABC. Now, we will locate C, we will join this and we get ABC, right. This is the triangle we are talking about. Now, this is the condition, these are the conditions which possibly this triangle can take, and this is how you will arrive at. Now, here I am not discussing, currently I am not discussing how will you draw these planes when they are doubly inclined. The fundamental will remain the same, we will arrive at the reference rectangle and we will then locate the point, but this we will come subsequently once you have understood these basic concepts. Okay. We will move on to another one. Now, this here I have taken an irregular shape. Till now we were taking very simple shapes. This is a quadrilateral where we have A, B, C, D. Okay. Now, this C, D of course we can enclose within this reference rectangle, but for C we will again have to arrive at these dimensions. Let us quickly draw it, very simple. Okay. So, we will draw this reference rectangle which is A, B, E, F. So, A, B, E and F. Okay. Now, you have say this D already, we mark this Q and P, and when you will connect this Q and P, because Q is parallel to one of the axis, P is parallel to another axis. So, we arrive at this C. Now, you can draw your quadrilateral. Okay. This is what the final isometric drawing of this quadrilateral is going to be, if it is this condition. The same you can do if it is kept. Okay. So, you arrive at D, Q, P, come here, C, join them, simple. Okay. Again, so the fundamentals will remain the same, you will just have the same things repeating over and over again. I will do it again, you can keep doing it, have the grid papers ready with you, D, A, B, Q, P, F, E and this point is C, you join it, and every time you will get a slightly different looking, I say it, you get a different looking shape, but it is actually the same isometric. Okay. Now, if you have to do the same thing, you have to incline it to any one of the planes, you can again go back, draw the orthographic projection, arrive at the reference rectangles in front and in the front elevation and top view, and then you bring it back onto the isometric drawing. So, you will try doing this, and in case you have a problem you can come back to me. You can do it for any object. Okay. Here we are looking at these quadrilateral and polygons. So, suppose pentagon is there, again the same thing, simple rectangle like this. So, D, C, this and this, and you arrive at this. The same thing, because it is a rectangle, suppose it is rotated like this, and this becomes the smaller side, you will have a different looking pentagon. So, the pentagon remains the same, but what you see as isometric drawing is slightly different, but if you measure it, it will exactly be the same. Okay. So, you can, another thing, one thing that you have to very clearly remember is that you cannot measure the non-isometric lines, you can never measure them and you should not measure them. Okay. Sometimes they will be elongated, sometimes they will be diminished, for example, this one and this one here. If you look at it in the original pentagon, they are all equal, right? But when you draw it in isometric, only the ones which are isometric lines, they can be measured, the rest cannot be measured, they can only be visualized. Okay. So, never try to measure the non-isometric lines, you should only measure the isometric lines. Now, in case you have to actually arrive at the original dimensions, then you should measure where the C is in relation to this, where this D is in relation to this line, where this point is in relation to this line, and that is how you will actually be arriving at the actual object, but not by measuring these non-isometric lines, never. So, this is another thing that you will keep in mind, and similarly you can actually draw any particular condition in which the plane is kept. Same another one. Okay. So, this is pentagon, now this one is hexagon. So, you will I am drawing it in very simple, but it is not going to be simple all the time. Okay. So, this is how you will draw your hexagon. Now, what I can actually do is I can measure two of the sides here. So, we have this one and this one, but we cannot measure these ones because these are non-isometric, but you will get this rectangle, this hexagon. Suppose I make it like this, I get a different looking hexagon. Okay. So, this is how you get another hexagon. It will appear to be a regular hexagon, but if you measure the sides, they will not be equal. That is what the trick of isometric drawing is. You cannot measure it if it is non-isometric. So, I hope you will try drawing any polygon that you come across with in isometric drawing, and you can assume any condition, you can try to draw them, and in case you find any problem, you can write to us and we will try to resolve your query. So, that is all in the lecture today. Thank you very much for joining me. Bye-bye.